Okay, welcome back to Tech Talks Education. We are going to continue with the calculation involving equation, that is the stoichiometric calculations. So in this session, we are going to see if some volume of carbon dioxide, or the volume of a gas has been produced, what could be the mass of the substance that produced that volume? So let us look at some examples here. Lead to nitrate decomposes according to the following equation. So 2 moles of lead to nitrate decomposes to produce 2 moles of lead to oxide, 4 moles of nitrogen dioxide, and a mole of oxygen gas. So calculate the mass of lead to nitrate that decomposes completely to produce to produce 5.6 liters of nitrogen dioxide at STP. Oh, this time we are using liters instead of cubic centimeters and cubic decimeters as we had seen before. So let us look at the solution. Identifying the chemical species to use. Lead to nitrate. Then I'm going to also use nitrogen dioxide. Meaning that I'm not going to touch lead to oxide, I'm not touching oxygen gas. We are only using these two. And for lead to nitrate, we are going to look for its mass, meaning that these 2 moles of lead to nitrate, we shall convert them to mass. And then for the nitrogen dioxide gas, we are going to convert it to volume in liters. So let us see what has been added for us here. That lead, the relative atomic mass is 207, nitrogen is 14, oxygen is 16, and then 1 mole of a gas at STP has a volume of 22.4 liters. So we are going to use this in getting what we want. First of all, lead to nitrate, we shall deal with its mass. So let us convert lead to nitrate into, these 2 moles of lead to nitrate into mass. Now, for the sake of simplicity, let us firstly get the mass of 1 mole of lead to nitrate. 1 mole of lead to nitrate has a mass of 207 plus 14 times 2, that is 2 atoms of nitrogen, because 2 is outside this bracket and everything in the bracket will be multiplied by 2, the number of atoms, plus oxygen is 16 times 3 oxygen atoms times the 2 oxygen atoms, times the 2 which is outside here, times 2. So if we work out this one, we get 331 grams. So that is the mass of 1 mole of lead to nitrate. And then we have also 4 moles of nitrogen dioxide. So the 4 moles of nitrogen dioxide, we are going to get its volume by multiplying the molar gas volume by 4. Let's go straight to first principles. So we are going to make nitrogen dioxide to be on our left hand side and lead to nitrate to be on the right hand side, because we are looking for the mass of lead to nitrate. Whatever we are calculating goes to our right hand side. We are starting with nitrogen dioxide. But there are 4 moles from this equation, so we shall say 4 times 22.4 liters of nitrogen dioxide is produced by, take note of this, we cannot have a product producing a reactant. We cannot say it produces this lead to nitrate. No, it is produced by lead to nitrate. That is the correct word that we should use. So 4 by 22.4 liters of nitrogen dioxide is produced by, then we go to lead to nitrate. 1 mole is 331 grams, but there are 2 moles here. We don't have to ignore the number of moles. So it is produced by 2 times 331 grams of lead to nitrate. Then what of this volume here? The 5.6 liters of nitrogen dioxide gas is produced by, then we cross multiply, it will be 2 by 331 by 5.6, we are cross multiplying directly, over 4 over 22.4, and the unit is grams of lead to nitrate. So let us get the answer from this using our calculator. So it is 2 times 331 times 5.6 divide by 4 divide by 22.4. Remember, 4 and 22.4 are both denominators. So we are going to keep on dividing the answers we are getting by them. Don't say divide by 4 and then you multiply by this, because when you just multiply, it will take this one back to, it will become a numerator. So it gives you a wrong answer. So what I've got from here is 41.375 grams. So this is the mass of lead to nitrate that produces the 5.6 liters of nitrogen dioxide. What we are calculating goes to our right hand side, and that's what we have done exactly here. So that is good. Let us look at another example which is related to this, when we are still calculating the mass of a reactant that produces a given amount of, or a given volume of a gas. So let us look at one simple and a very interesting example. Let's look at this. Calcium carbonate reacts with dilute hydrochloric acid according to the following equation. So calcium carbonate reacts with hydrochloric acid to produce calcium chloride solution. Why is it a solution? It is a soluble salt. If it was an insoluble salt, then it would be precipitated, and that one is dangerous because it would form a protective layer on the outer surface of the calcium carbonate, and the layer will have to prevent further reaction between the acid and then calcium carbonate. Because the acid cannot come into contact with calcium carbonate, there is a layer already of the insoluble salt. So this one here is okay because it is a soluble salt. It will not form that protective coat or protective layer on the outer surface of the calcium carbonate lumps. So we also get water as a product, and we get carbon dioxide gas. Let's balance the equation for the reaction. One calcium atom on the reactant side, also one on the product side. One carbon atom on the reactant side, on the product side also one. 3 oxygen atoms on the reactant side. 1 plus these 2 is 3 oxygen atoms balanced. Hydrogen atoms, one hydrogen atom here we have 2. We multiply hydrochloric acid by 2, and then the number of chlorine atoms goes automatically to 2. Here we also have 2. So our equation is balanced. So we should calculate the mass of calcium carbonate required to react with excess dilute hydrochloric acid to produce 6 cubic decimeters of carbon dioxide at the standard condition is room temperature. Again, we have the relative atomic mass of calcium being 40. We have got the relative atomic mass of carbon being 12. Oxygen is 16. Then the molar gas volume, that's 1 mole of a gas at room temperature. Occupies 24. The unit must be the same, 24 cubic decimeters. Okay, we are good to go. We are dealing with calcium carbonate. Good. We are dealing with it. Required to react with excess dilute hydrochloric acid. It is in excess, no specific quantity. So anything which is in excess is not having its specific quantity given, so we ignore it, we don't use it in our calculation. To produce a definite quantity of carbon dioxide, 6 cubic decimeters of carbon dioxide at room temperature. So we are also going to use carbon dioxide. We are not using this, we are not going to use this, we are not going to use hydrochloric acid. So since we are dealing with the mass of calcium carbonate, we have 1 mole of calcium carbonate. So let us convert it to mass. So the molar mass of calcium carbonate is 40 plus 12 plus 16 times 3, and this one gives us 40 and 12 gives us 52 plus 48 is 100 grams. That is the mass of 1 mole of calcium carbonate, or the molar mass of calcium carbonate. But what are we calculating? We are calculating the mass of calcium carbonate. Therefore, calcium carbonate goes to our right hand side, and carbon dioxide and its volume comes to our left hand side. 1 mole of carbon dioxide, its volume is 24 cubic decimeters. Then we say 24 cubic decimeters of carbon dioxide gas is produced by, calcium carbonate. 1 mole is 100 grams of calcium carbonate. What of the 6 cubic decimeters? The 6 cubic decimeters of carbon dioxide is produced by Then we cross multiply 100 times 6 divided by 24 grams of calcium carbonate. And what do we get in this case? Let us use our calculator. 100 times 6 and we divide by 24. The answer is 25 grams. So that is our mass of calcium carbonate that produces 6 cubic decimeters of carbon dioxide gas at room temperature when it decomposes completely. So I believe that this reaction here, we met it somewhere in the preparation of carbon dioxide gas in the laboratory. We said that the acid which is being used and then the carbonate that is being used in the reaction should react and produce a soluble salt. And this soluble salt which is produced will be produced as a solution which does not tamper with the reaction or the continuation of the reaction, in that if at all it was an insoluble salt, then if the insoluble salt which is formed as a solid would be deposited on the outer surface of the calcium carbonate as a precipitate or of the carbonate salt, and then it blocks it from further reacting with the acid and the reaction stops. Otherwise, this one is the correct reaction that leads to the formation of carbon dioxide gas continuously. And this is how to go about with the calculation of mass, when the mass is the mass of a reactant reacting to produce a gas, in this case when we have been given the volume of the gas. So make sure that if it is a product being formed, then you say the product is produced by the reactant. But if you are calculating, in this case, if we have a reactant producing a product, then we say that this reactant is